The waves on Saturn's rings don't just look beautiful, they tell time. According to NASA, the distance between each wave crest can represent 4 years of propagation caused by gravitational interactions. In fact, by reading these patterns, scientists have reconstructed decades of orbital history of Saturn's moons, especially Janus and Epimetheus. This method is akin to reading tree rings, nature encoding time in elegant patterns. But the moons themselves hold even deeper secrets. Among Saturn's many satellites, 2 changed the course of planetary science forever: Titan and Enceladus. Let's begin with Titan. The second largest moon in the solar system. Larger than Mercury, Titan has a thick, nitrogen-rich atmosphere. It's the only moon we know of with a substantial atmosphere and/or liquid lakes. On its surface, not of water, but liquid methane and ethane. The Huygens probe, carried aboard Cassini, detached and descended onto Titan's surface in 2005. It parachuted through Titan's orange haze, capturing surreal photos and analyzing atmospheric composition along the way. When it landed, it transmitted data for over 72 minutes, the first and only landing on a world in the outer solar system. Titan looked eerily Earth-like. River channels, shoreline patterns, erosion. But it was alien. Freezing temperatures, hydrocarbon rain, and an orange sky. Scientists believe that Titan may mirror early Earth, offering clues to how life might have once started on our own planet, or how it could arise elsewhere. Next, Enceladus. Tiny ice-covered moon just 500 kilometers across. It was expected to be geologically dead. Cassini proved otherwise. In 2005, Cassini observed plumes of water vapor erupting from Enceladus's south pole. These geysers blasted through fractures known as tiger stripes. The implications were astonishing. A global subsurface ocean beneath its icy shell. Even more shocking, Cassini flew through the plumes and detected water, salts, organics, and hydrogen. Ingredients for life. Enceladus had gone from obscurity to becoming one of the most promising places in our solar system to search for alien life. Both Titan and Enceladus challenged our assumptions. Who would have thought that frozen moons could host liquid oceans or complex chemistry? That these worlds, orbiting far from the sun, could become frontiers in the search for life? Cassini continued studying them both. It mapped Titan's methane storms, watched its changing seasons, and captured reflections of sunlight glinting off its lakes. It flew by Enceladus repeatedly, analyzing its spray, measuring its gravity, and photographing its fractured surface. The discoveries rewrote textbooks and shifted priorities in planetary science. Future missions are now being planned to return to these worlds, including NASA's Dragonfly mission to Titan, which will send a flying drone to explore its diverse terrain. As we continue through this saga on Infinity Beyond, remember that Cassini didn't just orbit Saturn. It gave us a deeper understanding of what it means to be alive in the cosmos. It showed us that even in the far reaches of our solar system, oceans can hide beneath ice, atmospheres can glow orange, and mysteries can lie beneath every crater. Up next in Segment 4, Saturn's Rings, a symphony of ice and gravity.